On this computer. Hello, everybody. Welcome to our lightning talk session for January 30th, 2023. I believe everybody can see my screen. This is, I don't know, our fourth or fifth lightning talk, so we should be pretty good at the general ground rules here. So the presenter is going to have roughly 5 minutes to present. Please, no questions or comments during the presentation. In fact, if you can mute yourself, that would be helpful. As the talk is underway or just before, I'll create a thread in the Lightning Talk Google chat space. And if you're not in that space already, just send me a message on Google Chat. I'll add you. You can post questions, comments, compliments in that thread. And the presenter will address the comments after their presentation. And as you all know, the meeting is being recorded. So let's get to our list for today. So today we're going to start off with Diane. She's going to talk about OAuth 2.0. Prashant has a presentation called Just Don't. And Stephen is going to talk to us about estimation and continuous improvement. And then I'm going to follow up with a talk on using Git bisect. So without further ado, I will stop sharing my screen and I will kick it over to Diane to start sharing hers.
All right. Sharing now. Can someone confirm?
Yes.
Thank you.
Yep.
All right, let's get started. Hello, everyone. My name is Diane Bungaydin, and I will talk about OAuth 2.0 in 5 minutes. So, you may have noticed when logging in or registering on a website that you are given other options to log in. For example, you're on Etsy.com, you want to create an account, and you see these other options to continue with Google or Facebook or Apple. Say you sign in using Google, you are asked to enter your username and your password, and you are also asked or informed that some of your information, such as your name, your email address, language preference, etc., will be shared with that website, which is Etsy. Then you will have to explicitly select authorize or consent, or in Google's case, just the word next. And voila! You now have an account on Etsy with your name and email that came from Google. This was all made possible by OAuth 2.0. OAuth 2.0 is an industry standard for authorization. But what is it and why the need for an industry standard protocol? Let's do a little bit of history. So back then, if you want a website to access your information from another site, you have to provide those credentials to that other site. For example, you're interested in this new budgeting website called shadybudgetplanner.com. And you want to link your banking information to this website. And so to do that, you have to provide your bank login, username, and password to this shadybudgetplanner.com. This is very insecure. You know, the site itself could be malicious, or there could be someone phishing and they can gain access to your credentials. And so because of that, more secure practices were implemented. Now, the other problem that came with that is everybody created their own protocols to avoid such kind of problem. And so Microsoft had one, Google had one, and it made it difficult for developers to work with. And so an industry standard protocol was born. That is OAuth. Let's briefly cover some OAuth concepts. First one are scopes. These are items that the user allows or denies to have access to. In our example, that was my name and email address that I consented Google to share with Etsy. Next are actors. There's 4 of them. First is the resource owner, the one who owns the data. In my example, that's me. I own the name and email address. There's the resource server, where we store the resource data. In our example, Google. There's a client, which is the application that wants access to the data. That's Etsy. And the authorization server, the main engine for OAuth. And in this example, it happens to also be Google, but this can be a completely separate server. There are different flows or grants in OAuth, and to understand what these actors do, I will describe one of these flows for this presentation. I'm going to focus on authorization code. Here's our diagram for that. These are our 4 actors. Here's me, the resource owner. This is what I look like in real life. Our client is Etsy. Our authorization server and resource server are both Google in this case. So let's look at the flow here. So really there's probably like a step 0 here, which is me going to Etsy so that I can log in, right? But the real off-code flow starts when the client asks the authorization server for an authorization code. At that point, the authorization server will prompt me for authentication details, my username and my password, and asks for my consent, like I've shown earlier. Let me go back to slide 3 real quick to show you that when I had to enter my username and password, I am in the google.com domain and not in etsy.com. This makes it secure because my username and password doesn't travel in the network between the two domains. I just put my credentials within Google. Going back to the diagram. Once I have that, I get the authorization code. And from the authorization code, I provide also a client ID, client secret to get an access token. And this access token is what I need to get the resources, which is the scope, my name and email address from the resource server. And that is what Etsy used to create my account. And so just a few last things. If you're a developer and you want to build your own authorization server, you can use some open source or commercial frameworks, or you can use some identity as a service provider like these that I have on the screen. That's OAuth 2.0 in 5 minutes. Thank you for listening.
Awesome. Great, Diane. Thank you very much. Up next, we have Prashant. Prashant, if you can go ahead and share your screen for the presentation and get going.
All right, can everybody hear me and or see my screen?
Yes.
All right, cool. Just let me get set up real quickly. Start the timer and off we go. All right, yeah, this should probably be a short talk, but yeah, but this is a talk called Just Don't. Yeah, my name is Prashant Punjabi. Good to be here. This talk was more or less inspired by an essay I read on Tim Bray's blog. Tim Bray is the inventor of XML, and but you know, I've been following him for a while. I guess, you know, reading some of the stuff that he puts out. But this was like a really, like, you know, I would say an interesting article. Like, it was something so low level and something so trivial. I was excited to see that, you know, even somebody who's sort of so accomplished also sometimes thinks about things, you know, like some of the things that I think about a lot of the times during, you know, working in teams and whatnot, right? Things like that. So now think about this, right? So if you're joining a new team, you know, you're a new member of the team has, you know, they have a couple applications that they maintain and they develop and they improve over the time. And, you know, obviously you're new on the team, so you don't really know exactly what's gone on in the past. There's been a lot of changes. Obviously, the product owner has changed, the leadership has changed, the development team has turned over. And now you're in a meeting and you're trying to, you know, figure out along with your team how to improve it, how to implement a couple of new features, and you know, how to, you know, just sort of, you know, figure out what to do next. Some of the things, sometimes you don't understand a few things, sometimes you're just trying to present your ideas, right? So now, you know, you can be very tempted to say something like, can't you just you know, do this? Why didn't you all just do that? You know, you try to give your suggestions in a way that you know, working with the team to kind of figure this out, right? So this is the idea, is that what I'm trying to say is that when you say something like this in this way, it can, you know, definitely alienate. At worst, it can, you know, belittle the people that you're talking to, right? So the idea, the person that you're asking the question, basically what you're trying to, what you might come across, how you might come across is that they, you know, they had no idea what they were doing. It was something that was so obvious, and they completely missed, you know, something that you know, something so obvious, and they never even thought of that before, right? So that is something that, you know, we try to avoid. So this is a kind of an excerpt from the essay that I read, Tim Bray's article. It kind of really did a deep dive into the word just, and you know, he found in the Oxford English dictionary the definition that he was looking for, right? The idea is that in that he found you're trying to represent as a small thing something that somebody else is doing, right? So that's what you don't want to do, right? You don't want to try to get into, you don't know how somebody who you're talking to feels about what they've been asked. The word justice, it could be a signal that you're not taking their problem seriously, right? So that's what we're trying to do, not to do, sorry. So what could you do instead, right? So what you could do instead is say something like, have you considered? You could say something, do you know about something? You could say, what if you tried this and that? The idea is to orient your communication in a way that can be more collaborative and not something that is, can alienate or belittle people, right? So yeah, that's more or less what I was trying to say. And there's a few other things that, in the same vein that I try to avoid, or sometimes I think about when these come up. One of the words is obviously, not everything is obvious to everybody, right? So this is an obligatory XKCD that talks about that. Here we are, I think this was for everything that is obvious to everybody else. There's about 10,000 people in the US every day, that learn about that for the first time, right? And also, if you try to say that, you try to, if you introduce something that is obvious to you to some that may not be obvious to somebody else, that can be fun, right? You kind of get to kind of show them something that they didn't know about, right? I think about things all the time, like, one of the examples of this is, like a shortcut in a terminal or in your IDE or something like that, right? It may be obvious to you, but not everybody does that. Looks like this is more or less on the other side of the spectrum. I find myself always editing comments and in Slack messages to say, looks like the server is down, looks like there's a bug. There is a bug. All the servers down. Everybody knows that, right? Again, that's another one that takes me out, especially in communication. Examples of this is now consider the alternatives that we just thought about. I feel like replacing you with we, greatly improves them, right? It does foster a more team mindset, a more collaborative mindset. So yeah, that's something that we were trying to consider. Let's see. And also, again, finally, if you find yourself saying this, if you think about this a lot, definitely, be gentle with yourself. We are all making this up as we go along. Assuming positive intent and giving people the benefit of the doubt goes a long way in promoting a more collaborative work culture, and also, saving yourself some trouble in trying to figure out what people were trying to convey and what the intention was. Yeah, thank you. And yeah, do tell me in your comments if you have similar pet peeves. Would love to listen to get to see what if you all think about things like that as well. And these are a few links here. And the last one I'd point out is the Key and Peele sketch, which I may or may not have watched many times while researching this presentation. Thanks a lot for your time. I'm going to stop here.
Thank you, Prashant. Yeah, if other people have thoughts and opinions on this, the Google chat is a good place to have a conversation about that. Next up, we have Stephen with estimation and continuous improvement. So I think, Prashant, you just need to stop sharing.
Yeah, I'm trying to find that. Hold on. Oh, here it is.
It's like a big red stop sharing or something at the top.
You just take over.
Yeah, Stephen, if you go to share, does it let you take over?
Why am I not seeing it? Damn it.
Oh, my system preferences are down, so I gotta quit and reopen really quick.
It'll take
there it is. Yeah.
Figure out how to stop sharing. There he goes.
I was looking at the gallery view and I couldn't see the stop share was in the toolbar or something.
Yeah, it's like the top thing. Yeah, and while Stephen is coming on, we definitely have a rule amongst us when we get together in some of our meetings where we're not allowed to, I'll say anymore because we used to do it all the time. We're not allowed to anymore. Say things like, you don't know XYZ, or you didn't know.
Yeah, you don't know.
Yeah. All right. If that's Stephen, I can see your screen.
Cool. All right, let me move this. This is not allowing me to grab. Oh, there we go. All right. View slideshow. Okay, can everyone hear me okay?
Yep.
Okay, great. Hello, everybody. My name is Stephen, and my lightning talk today is on estimation and continuous improvement. So last year, I set a goal for myself to deliver more accurate estimates to my clients, as well as record those estimates and reflect on those and see where I went wrong, see where I could improve, and overall just create a better method to what I was generating those estimates for. So I want to go through some terminology that you might see later in this presentation. Development time, this includes time writing code, time spent testing code as well. So this can include unit testing, writing code to fix feedback that you've gotten from pull requests, anything like that. Feedback worst case, this is something that you can kind of estimate additional feedback time from client feedback. So you have to keep that in mind as well during your estimates. Release change amounts, this is a number between 0 and 1. So 0 meaning you have no doubt that this is what the client wants, which is very rare, as you may know. And then 1 meaning you're confident that the client is going to hate what you've written and you're going to have to change everything. If it's on either end of the spectrum here, then there might be something wrong. And then deployment time. This is the time it'll take to deploy changes to staging environments, QA environments, production environments. This is something that we often forget in making estimates, but if you have external teams that have that do server maintenance, or you have some sort of deployment scheme, this might add on to your estimate. So when I first started out giving estimates to clients, this was my very naive approach. I basically just said, this will take about 3 hours. So this is how much I estimate this ticket for. Obviously, this is very naive. This didn't account for issues that maybe with the code, it wasn't what I thought it was. It wasn't maintained the way I initially thought. And so it took more time to develop this feature. So this didn't last very long. I gave some estimates that weren't very accurate because of this. So kind of an evolution of this approach, I realized, well, I'm going over my estimated development time a little bit. So I'm just going to double it. Now, this worked for a little bit, but in terms of, it doesn't scale very well in terms of larger estimates. So I was ending up going very under my estimates now instead of going over. And my current approach, now we're cooking. It's a little bit more complicated. So if I haven't done this feature or this haven't fixed a bug similar to this ticket before, I first research libraries, design patterns, any kind of reuse, or research any sort of problems that are similar online. And then I want to keep in mind, once I find the problem, how well it's documented, how well, if there is a library I can find, how well that library is maintained, and then keep all that in mind and add that development time to my estimate. Now, another issue is requirements may not be set in stone by the client. We also want to think about how much change the client may want. And these are where these other variables are coming in play. So feedback worst case, so let's say you estimate this to be like, in the worst case, the client may want to change everything. So I might put 5 hours on this feedback worst case. And then release change amount might be 0.5, because maybe I'm not sure if they want to change everything about it, but they might not like everything about it. So that's where I'm finding that part here. And then lastly, I want to add on development time. So I got to think about if there's any external, like a third party that has that maintains the server for me, that can add on as well, communicating with them over email or whatever. And then any deployment techniques or deployment strategies that your team may have, that'll add on to the estimate as well. So now we're going to go to that second part of my goal, was to kind of look at my previous estimates and see where I could improve. So I want to open that up here. So this document I have basically just lists the clients I have, obviously cleansed for today, but lists the tasks, the estimate I gave, which in this first case is a 30-hour estimate, how much I actually worked on the ticket from start to finish. So this one I put 13, and then the difference between the two, and then kind of notes and reflections. So I want to go into one of these in detail and kind of explain why it became kind of a larger estimate, or I went over estimate. So for this first one, this was my first Rails upgrade, which is kind of the underlying framework of the project. I have notes here. The estimate was much higher, as this was my first time doing a Rails upgrade. So I padded for a lot of code sniff and other issues for gem dependencies based on the Rails version we were on. This was likely one of those estimates that I gave where I kind of doubled my estimate. So I was actually pretty accurate if I kept it at 15. And so this was an example of where I went a little too far over. This is an example of one of the newer estimates I've done. So I gave an initial estimate of 15 hours and it took 12.5 hours. This one, after some experience, I used my new methodology and it got a lot closer to my actual estimate. So yeah, that was my talk. I hope you guys enjoyed.
Thanks, Stephen. Excellent. Okay, let me share my screen, of course. Now it's at the bottom. It used to be at the top. All right, so my talk today is about Git bisect. And this is a great tool that uses binary search to find the commit that introduced a bug or introduced any change that you're looking for, to be honest. So what do we mean? We've all been, or those of us who are on the development side and we use version control, we use Git, we've been in this situation where, hey, whatever we're looking at right now is broken. We've got a broken commit that we know about. We've got a good commit in the past where everything worked fine. And somewhere in between, the code broke. So what do we typically do? Well, in the past, we'll check out a commit somewhere in the middle, see if it's broken, then we'll see, oh, it's still working there. Let's go somewhere else. And eventually we'll hone in on where the commit broke the application. And from there, it's sometimes often easy to see what the problem is. So what Git bisect does is tries to use binary search to split the commits in half. With your help, you can probably in much greater speed hone in on the commit that is breaking your application. So we're going to go right to a demo because that's more fun. So I created a very simple React application. I called it traffic signal test. If you click on the picture, it cycles through a traffic signal the way you normally would see it in the wild. You also can manually set the light to red or to yellow. There are some statistics at the bottom, but we currently have a bug. When I click set green, it's going to set the red light. Okay, contrived, very simple problem. But let's use Git bisect to figure out which commit introduced this bug. If I look at my list of commits, I'm currently on the head of main, which is up here. And I know in the past that I had a commit that was working, or at least is far enough in the past where things worked. And I'm going to go all the way back to the good commit. Let's see, from somewhere back here. I picked one, obviously. That's the initial traffic light image working. Okay, so let me go to my terminal. The rest of this, or most of this, is going to take place in the terminal. So we're going to look at this next. So traffic signal. So what do? I start with get bisect start. And I have to tell it that I've got a bad commit somewhere. Since I'm currently on a bad commit, I can just say get bisect bad. And then for my good commit, all I need to do, and I'm going to copy paste from somewhere else, so I don't have to. I say get bisect good, and I give it the hash of the good commit. So that's the one in the past. What Git will do is it will say, okay, I've just checked out this commit. There's about 7 revisions left to test and about 3 steps. So what it wants me to do, though, is tell it whether I'm currently sitting on a good commit or a bad commit. So I go back to my application and just going to refresh just to make sure, since I last looked at this yesterday, I shouldn't have to refresh each step. And I'll see, is this broken or is this working? So set yellow, set red, set green, still broken. So I just have to say get bisect bad. It checks out the next version. And as you can see, I'm going back in time. So the application is getting less functional. But let's see, I could click on this, it still works. Make red. I actually switched where the buttons were to make myself even more confused. Make yellow, make green. Okay, that works. So now I just have to say get bisect good. It updates again. Again, I want to follow the same procedures. Here, it's broken. I'm clicking make green, it's going to red. So get bisect bad. One more to test. Make red. Make green is still broken. So it's done. What does it tell me? Hey, this is the bad commit right here. The one with the comment setup stats. So let's look at that guy. Setup stats right here. So obviously I had some state here where I set up my statistics. And this was me cycling through the lights. And what's this change? Oh, there's a forced light command that used to say green when you said make green. Now it says red. That's the issue. So this is exactly what the problem was. I can fix this and move forward. So get bisect helped me hone in on that problem. Now, there are definitely a few options for get bisect that you'd want to explore if you look at the documentation. So the get bisect documentation is here. It's your typical Git documentation. But one that I wanted to sort of highlight was the ability to actually have a script run that will facilitate whether you have a good or a bad commit. So I have a calculator application that really doesn't, it just has add, subtract, multiply, divide. Let me go to it, sorry. Here it is. And I actually have a bunch of tests, unit tests that I wrote for it. And currently in the head of the application, my unit tests are breaking. So again, I want to figure, again, this is contrived and hopefully your continuous integration will tell you if unit tests break when a particular commit goes in. But in this example, let's sort of pretend that I'm in this situation right now where my tests are breaking. You can see one failed. It was my add test. And so what I want to do, again, I'm going to get bisect start and get bisect bad. I already have a script that I created, and apologies, I got to go to my sticky here. I got to tell it the good. So I'm going to go back in history, tell it which was a good commit back in time. And then instead of every time saying get bisect bad, get bisect good, and running the tests myself, I can actually say get bisect run and run a shell script. And this shell script just does an npm run test. So if I hit enter on this, it's going to run my script. It's going to run my tests. If the tests fail, it will mark that commit as bad. If they succeed, it will mark that test as good. So as you can see, they passed, so it went back, and it's going to continue doing this in the same way. What I've done is just sort of circumvented my manual interaction that was needed. And eventually it's going to hone in on the bad commit. So let's give it another 5 seconds or so. I'm probably over my 5 minutes, I'm sure. And again, same kind of thing. It tells me that this is the first bad commit. It's the one where I added the power to operation. So here it is. Let's look at that one. Well, here's where I added power to, and oh, sure, I changed my add function from a plus b to a times b. Of course, that broke my tests. So again, it helped me find the commit that caused the problem. it can hopefully, again, it's just another tool in your tool belt that can help you in situations. I found it helpful and definitely a bunch of situations over the last few years of just trying to circumvent having to manually do that step that some of us have done before. We've tried to find different commits. Again, the documentation is great. You can do things like you can change the terms if you're looking for, you know, if you don't want to use bad and good and you want to use, you know, poor performer, good performer, you can test lots of different things in this way. So hopefully this has been useful. That is my talk. And so we are all done at this point. Hopefully everybody enjoyed the lightning talks today. Look for an invitation to contribute coming soon. We always want to keep a cadence going here. As you can see, as you're, you know, going about your daily business and working on your different applications and all parts of software development, if you find something interesting, if you find something that's a nugget of information or a tool, you know, we'd love to hear about it and hear you have some more people volunteer to do these lightning talks and spread that knowledge around. So thanks, everybody. I'm going to stop the recording now.